When using a non-metallic forks for box with a metal P-ring attached to non-metallic cable, the metal P-ring is generally not required to be bonded or grounded. The reason for this lies in the fundamental principles of grounding and bonding as they relate to electrical safety. Grounding and bonding are essential practices in electrical systems to minimize the risk of electric shock and ensure the safe operation of electrical equipment. Grounding refers to the connection of an electrical circuit or equipment to the earth, providing a low impedance path for fault currents to flow back to the source. This path helps to quickly trip a circuit breaker or fuse, interrupting the flow of electricity and preventing a dangerous voltage buildup on conductive surfaces. Bonding, on the other hand, involves connecting together all metal parts that are likely to become energized, creating an electrically conductive path that ensures they are at the same electrical potential. This equipotential bonding minimizes the voltage difference between these metal parts, reducing the risk of electric shock if someone comes into contact with them. In the context of a non-metallic box, the box itself is an insulating material and does not conduct electricity. Therefore, it does not pose a shock hazard and does not need to be grounded. The metal P-ring, which is attached to the box to provide support for wiring devices, might seem like a component that should be grounded. However, because the box is non-metallic, the P-ring is isolated from any potential electrical fault. Furthermore, non-metallic cable, which is commonly used in residential wiring, has an insulated outer jacket and does not have an exposed metal sheath that could become energized. The grounding conductor within the non-metallic cable is connected to the grounding terminal of the wiring device, such as a receptacle or switch, providing a path for fault currents to flow back to the source. This grounding conductor effectively protects against electrical shock in the event of a fault within the wiring device. The National Electrical Code, or NEC, provides specific guidelines for grounding and bonding electrical systems. According to the NEC, grounding is required for metal enclosures that house electrical conductors or equipment to ensure that any fault currents are safely conducted back to the source. However, the NEC does not require grounding or bonding of metal parts that are isolated from electrical circuits and do not pose a shock hazard. In the case of a non-metallic box with a metal P-ring, the P-ring is considered to be isolated because the box is non-conductive and the non-metallic cable does not have an exposed metal sheath. Therefore, the NEC does not require the P-ring to be grounded or bonded. There are a few exceptions to this general rule. Firstly, if the metal P-ring is likely to become energized due to its proximity to exposed electrical conductors or equipment, it may be necessary to ground or bond it. This situation could arise if the P-ring is in contact with a metal surface that is connected to an electrical circuit or if the wiring within the box is not properly insulated. Secondly, if the local electrical codes or regulations require grounding or bonding of metal P-rings in non-metallic boxes, then those requirements must be followed. Local codes can vary depending on the jurisdiction, and it is important to be aware of and comply with the applicable regulations. Thirdly, in some cases, it may be desirable to ground or bond the metal P-ring for additional safety or to minimize electromagnetic interference. Grounding the P-ring can help to reduce the risk of static electricity buildup and can also provide a path for stray currents to flow to ground. However, this is not typically required by the NEC or other electrical codes. To summarize, the general rule is that a metal P-ring on a non-metallic box is not required to be grounded or bonded when using non-metallic cable. The non-metallic box provides insulation and isolation, and the non-metallic cable does not have an exposed metal sheath that could become energized. However, there are exceptions to this rule, and it is important to consider the specific circumstances and applicable codes and regulations before making a decision. When in doubt, it is always best to consult with a qualified electrician to ensure that the electrical system is installed and maintained in accordance with all applicable safety standards. Proper grounding and bonding are essential for electrical safety, and it is important to understand the principles and requirements of these practices. By following the guidelines of the NEC and other electrical codes, electricians and homeowners can help to minimize the risk of electric shock and ensure the safe operation of electrical equipment. In addition, it's important to remember that electrical work can be dangerous, and it should only be performed by qualified individuals who have the necessary training and experience. Working with electricity can pose a risk of electric shock, electrocution, and other injuries. Always take precautions to protect yourself and others when working with electricity. Before starting any electrical work, disconnect the power supply to the circuit or equipment you will be working on. Use a voltage tester to verify that the power is off before touching any wires or component. Wear appropriate personal protective equipment such as insulated gloves and safety glasses. Follow all applicable codes and regulations and consult with a qualified electrician if you have any questions or concerns. Electricity is a powerful and essential part of modern life, but it can also be dangerous if it is not handled properly. By following safety precautions and seeking professional help when needed, you can minimize the risk of electrical accidents and ensure the safe operation of electrical systems. One additional point to consider is the type of wiring device that is being installed in the non-metallic box. If the wiring device has a metal faceplate or other exposed metal parts, it may be necessary to ground the device to protect against electric shock. The grounding conductor from the non-metallic cable should be connected to the grounding terminal of the wiring device, providing a path for fault currents to flow back to the source. This grounding connection helps to ensure that any exposed metal parts of the wiring device are at the same electrical potential as the grounding system, reducing the risk of electric shock if someone comes into contact with them. Furthermore, it is important to properly support the wiring device within the non-metallic box. The P-ring provides support for the wiring device, but it is also important to ensure that the device is securely fastened to the box. This will help to prevent the device from coming loose and creating a potential hazard. Use appropriate screws or other fasteners to secure the wiring device to the box, and make sure that the device is properly aligned and seated. In addition to grounding and bonding, another important aspect of electrical safety is overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow, which can cause overheating, fires, and other hazards. Circuit breakers and fuses are rated in amps, and they are designed to trip or blow when the current exceeds their rated value. This interrupts the flow of electricity and prevents damage to the circuit or equipment. It is important to select the correct size circuit breaker or fuse for each electrical circuit. The size of the overcurrent protection device should be based on the ampacity of the wires in the circuit and the load that the circuit is expected to carry. The NEC provides guidelines for selecting the appropriate size overcurrent protection device for different types of circuits. It is also important to regularly inspect circuit breakers and fuses to ensure that they are in good working condition. Circuit breakers should be tested periodically to verify that they trip properly, and fuses should be replaced if they are blown. Faulty or damaged overcurrent protection devices can fail to protect the circuit from overcurrents, increasing the risk of electrical hazards. In conclusion, electrical safety is a multifaceted topic that encompasses grounding, bonding, overcurrent protection, and other important practices. By understanding the principles and requirements of electrical safety, electricians and homeowners can help to minimize the risk of electrical accidents and ensure the safe operation of electrical systems. Always follow applicable codes and regulations, and consult with a qualified electrician if you have any questions or concerns. Remember, electricity is a valuable resource, but it must be handled with care and respect. The goal is to ensure that any exposed metal parts are maintained at ground potential or at least reliably connected to ground through a low impedance path. Also keep in mind the location of the New England area may have more stringent local codes.